kind of proposed and introduced to a few schools and sort of work with a few schools to sort of help the teachers design and develop mathematical modeling tasks. So since today the seminar is going to be on mathematical modeling, we'll talk about mathematical modeling. So this is roughly how my talk is going to progress. I'll start off with just a little bit on mathematical modeling, because I would assume that if you are here, you know a little bit about mathematical modeling. So I just a very brief and quick introduction to what is mathematical modeling, and I jump on to teaching mathematical modeling, or teaching of mathematical modeling, and of course then I'll describe to you the framework for teaching of mathematical modeling. So essentially that's going to be how I will conduct this talk. So let's start with mathematical modeling. I think the easiest way to sort of get a quick feel of what this is all about is through a schematic or diagram or illustration, if you like, to see how what exactly is mathematical modeling. In mathematical modeling, probably you've seen this before, we always start, or we tend to start with a problem in real life. Alright? And now I have a pointer. Alright, a real life problem, real world problem, and we would like to look for a real world solution for this problem. And usually that route there from the real world problem directly to a real world solution may not necessarily be easy or even possible at times. So we then, in mathematical modeling, turn that into a problem in the mathematical world. Maybe we need to make some assumptions to simplify the problem a little bit, then construct the model, solve the model, and then if we get a solution, we try to interpret the solution in the terms of the real world, and maybe through a process of model validation. Sometimes at this stage we find that perhaps the model is not good enough, and perhaps we need to refine it a little bit, and maybe we go back to the assumptions and we maybe relax some of the assumptions and make changes to the model, and that process is what we would call a model refinement. So roughly, this is a picture that can describe the process of mathematical modeling. But this is by no means the only diagram or graphic that you will find that would that describes mathematical modeling. I will show you a few others. Okay. For example, this one is from Professor Stillman and colleagues. I think in 2007 was a paper, and I don't have the full reference here, okay, but it's from Stillman and others. And essentially, if you look at this diagram, it's still the same thing. You start with a messy real-life problem, and then you try to construct a mathematical model to solve it. Here's another one, Bloom and his colleagues. Okay, same thing. They start with a real situation or problem, and then moving on to a mathematical model, and then solving it, and they call it mathematical results. It's the same thing as a mathematical solution. And here's another one. This is from the document for the curriculum in the New South Wales Department of Education and Training. Well, we see the same pattern. We start again in stage one, they call it, with a real world problem, and then going through formulating a mathematical problem and then solving the mathematical problem. So you see the pattern. It's essentially the same thing. Beginning with a real world problem, the intent is to find a real world solution. And essentially you do that by casting the problem into a mathematical problem and then solving it to find a mathematical solution. So the essential components, essential elements, if you like, are all there, and they all say the same thing. So I think with that kind of general overview, we get a sort of a rough idea, picture, a big picture, overview of what mathematical modeling is about. Okay, fine. So now we move on to the next part, which is teaching mathematical modeling. What do we mean when we say we teach mathematical modeling? Is it a topic? Is it like a topic, a skill, like your trigonometry or your probability or your functions and graphs or algebra? Well, what do we actually teach in a mathematical modeling class or activity? I think this is, of course, just my opinion. I think we can teach techniques and skills that are used in typical modeling situations and activities. We provide learning experiences where students can practice these skills and learn the techniques. We can also discuss and use established or existing models, develop new models, construct new models for old problems. We can apply those existing models to new problems maybe. So these are all instances or examples of what we mean when we say we teach mathematical modeling. And of course, I think in many schools and for many teachers, you're very concerned about assessment. Okay, when you teach something, you want to be able to assess. So in mathematical modeling, you can talk about assessing specific skills. Okay, modeling skills. Now, also in my opinion, I think that in order for students to be able to develop and acquire modeling competencies, they need very meaningful modeling tasks and activities. Alright? Now, the tasks that you redesign for students need not necessarily always be very large-scale tasks. It can be small-scale, it can be even classroom seat work. And sometimes maybe pair work and so on, not necessarily every time we talk about modeling tasks, it has to be a huge 1 week program, not necessarily. Right. In addition, these tasks may be specially designed for some specific sub-competencies. For example, perhaps I think later on one of the schools will present using a particular function or particular feature of a graphics calculator, for instance, to solve a problem. And the idea is to develop the skills in the students, develop the skills of using that particular feature in order to solve some real-life problem. It can be as simple as that, right? But I think it's also important for teachers to be able to differentiate between what's problem solving, mathematical applications, and mathematical modeling. I will not go into the details, but there are teachers and students and other people who get confused between what's application and modeling. And I think it's important for us to be able to distinguish between that. Generally speaking, when we talk about application, we have learned the mathematics, and we want to be able to apply the mathematics. So in mathematical application, generally what we are talking about is that we have this piece of mathematics, and we look for situations where we can apply this piece of mathematics to solve some problems. Whereas in mathematical modeling, as you have seen earlier on, we usually start with a problem, not the mathematics. We start with a real-life problem, and then we look around and see what kind of mathematics I can use to solve that problem. So you may have one problem but many different solutions using different topics in mathematics, using different mathematical skills, for instance, to solve that problem, or to tackle the problem. Okay, so by now, perhaps after listening to me for a while, you feel a little bit bored. Yeah, I know all this, but how do I do it? I know what I must teach and so on, but how do I do it? So that's where the framework comes in. After working with teachers for a while and attempting to teach mathematical modeling for a while, I discovered that actually we need, for us, I do not know about teachers elsewhere in other countries, but For teachers here, local teachers here, I think it is useful to kind of differentiate between modeling skills and modeling competencies. Now, I would define modeling skills as the kind of skills needed for modeling. That doesn't explain very much, but would be things like knowledge in certain mathematical topics, maybe skills in using certain IT tools, skills in managing data, and so on. So general skills that has got to do with tackling a modeling task. Whereas competency, I would say that maybe that refers to things like the ability to make assumptions, the ability to say check out the other resources like the internet, magazines, etc. for more information about a particular problem. Maybe even the ability to write a report, to present and to defend one's model. That could be what we would understand as competency. Right? Now, suppose we accept those definitions, then perhaps we could define some kind of hierarchical levels for the different ways in which we can design our modeling tasks. Perhaps we could take as level one, a very basic level, where we attempt to teach or we help students learn those important modeling skills. And at level two, we help students, we facilitate the development of modeling competencies. And at a higher level, we hope that students, after having acquired those skills and developed the necessary competencies, are able to undertake a modeling task. Now, the reason why I am proposing these different levels of modeling activities or tasks is that I have discovered after working with teachers that some teachers can be very ambitious. They would design a task that would take maybe students 2 or 3 weeks to complete, and then they discover that it's not going to work because the students, they do not have the necessary skills, they do not have the necessary competencies. Some may not even know what do you mean by a model, what do you mean by assumptions. And I have come across a teacher who wanted to who designed a modeling task that requires a simulation model, and the students didn't even understand the meaning of the word simulation. So there's this big gap there, right? So the idea behind the framework is to try to bridge those gaps, to bring students slowly from maybe a novice or even a beginner or really a beginner who doesn't know anything about modeling and so on, up to a level where the students are able to at least tackle some kind of modeling task. Okay. So therefore, the framework that I have designed is to help teachers develop differentiated learning experiences in mathematical modeling. I have a competitor. Okay, so how does this framework look like? This framework just consists of 5 questions. The first question is, which level of learning experience? So obviously, because we are talking about different levels, so first question perhaps we need to ask ourselves is that if we would want to design a task, which level are we targeting? Okay. Then the next question will be what modeling skills or competency that we hope to that students will achieve or develop through this particular task. And then very important, where is the mathematics? Because if you are talking about mathematical modeling, there should be some mathematics within your activity, right? The next one, how to solve the problem. It's also very important for teachers to be able to have at least some idea of an approach to the solution of the problem. You can't just have a very fantastic modeling activity or task, but then nobody knows how to solve it. And but sometimes teachers do want to keep things very open and let students come up with their own solutions and so on. But I think it's also important for teachers to at least have the chance to get their hands dirty and work through the tasks themselves. Okay, and finally, why is this experience successful? I think it is important to be able to kind of evaluate the activity. So some of these questions I put up there are kind of a way to guide the teacher in designing a task or an activity. Alright, so which level of learning experience you might look at level 1, level 2, level 3, level 1 being very basic and probably a shorter kind of activity, and level 2 probably a very not too long or medium kind of duration of activity, and level 3 probably is something that is more full-blown kind of a modeling task. And what modeling skills or competencies, probably you need to state the problem very explicitly, and for the teacher list the competencies and skills that you would think you want to see develop in your students through the task, and perhaps you could list some sub-tasks that could help scaffold the activity. Whereas the mathematics, perhaps you could write down the kind of the actual mathematics that will be needed in tackling this problem, and it would be good if you can link that topic to your curriculum. Okay. How to solve the problem? I said before, it's good if the teacher is able to get your hands dirty and actually solve it. Go through the activity that you expect your students to go through. And finally, if you can list the expected outcome of your activity, perhaps you would like to see students being able to do something. And then if you can put that down explicitly and implementing or facilitating the activity, and you see those outcomes, then you know that that's what you have achieved, right? So another way to look at this model is, this framework is through this table here. If you have a table like this, all you need to do is to just fill up the right-hand side, and that kinds of helps you then in your lesson preparation or lesson planning part of your design. Okay. So I've introduced the framework that I just talked about to a few schools, and in a trial, I think that was the second half of 2011, right? And the teachers were introduced a framework in a very simple seminar, and then the teachers went on to plan and design lessons based on the framework with input from a few of us at NIE. And then at the, I think the first or second term of 2012, that's last year, the teachers implemented the modeling lessons, and then they are now invited to share this experience today. So that's in a nutshell what happened, and also the framework itself. So thank you very much.